Hi, a few years ago I used a LilyGo LoRaWAN module to track weather balloons and it turned out to be a really interesting project. If you have one of these boards, you can easily receive radio send signals they transmit, makes for a fun weekend project. These radio senders are used to measure various types of weather data and send it back for analysis. So the way it worked was you'd use one of these LoRaWAN modules and the radio senders would be flying several kilometers away from you. You'd pick up the signals transmitted by radio senders, track their GPS location, and then find out where they landed. It was really neat. Later I started thinking about using these LoRaWAN modules for other purposes. During my last trip to Asia, specifically Japan, I had some issues with phone communication. The coverage was spotty and I did not have enough data package to use the 5G network. I also had trouble connected with my friends right after landing cause I couldn't connect the airport Wi-Fi. There is a really impressive open source project called Meshtastic which aims to create a decentralized off-grid mesh network. It allows supported LoRa-based devices to send messages and these devices connect to your phone through Bluetooth. Messages travel from your device to others and if another device is out of the direct range, the message can hop through the intermediate nodes. All the communication is encrypted and this setup has enabled extremely long effective communication distances, reportedly up to about 331 kilometers. Very impressive. For the mesh communication itself, you don't need a phone. The phone is only used to interface with the device. If the LoRa device includes a GPS module, it can also transmit your location and related data. It's a very impressive project overall. To use Meshtastic, you need hardware that the firmware supports. Several platforms are compatible, the most common being ESP32 based boards, nRF52 based boards, and the Raspberry Pi Pico. Each platform has its own advantages and disadvantages. I got two LoRa modules and they look same from outside, both serving the same function but with some differences. Left one is called ThinkNode M1, has an RF52 840 microcontroller, and while the other one, ThinkNode M5, has an ESP32S3 chip. The ESP32S3 can connect to Wi-Fi and the MCU has more functions in general, but the NRF52 840 is very energy efficient than any ESP chips out there. Before we go any further, let's take a look at what's hidden beneath the casing so we can satisfy our curiosity. I've taken the PCBs out of the casing and disconnected the batteries, so let's take a closer look at what we've got here. This is the M5 version, which uses an ESP32S3 room module as a main microcontroller. And here is our GPS antenna connected to here, and we have our switches and buttons on the left. On the bottom left, we have an LED driver that controls the screen's backlight. If we go up a little bit, we have an 8-bit I/O expander. It works on I2C bus, and right next to it there is a USB to serial converter. Right side of the USB-C connector there is a lithium-ion battery charger for charging the battery. If we move upward near to the ESP32S3 room module, there is a real-time clock chip with a small battery that keeps the time even after reset. Let's take a look at the front side of the PCB. At the bottom there is a buzzer. Under the display there are two main components. The shielded one is the GPS module and the other chip is the LoRa transceiver chip. There are also some discrete components below, mainly used to drive the e-paper display and the backlight. They are not that interesting though. Let's look at the M1 version. In the middle, there is an empty area designated for the battery. And very close to that area, the nRF52 840 microcontroller, which is well known for its energy efficiency. They also use the same GPS antenna here, which is connected to the PCB through a connector. To the left of the USB connector, there is the same LED driver used for the screen backlights. And to the right side of the USB connector, there is a lithium-ion battery charger, the same one. Near the battery connector, there is a real-time clock IC for keeping the time, along with its small backup battery. The front side of the PCB is even more similar to the M5 version, and we also have a small buzzer here, and some discrete components used to drive the e-paper display. The layout beneath the display is identical to M5 version. We have the GPS module used to receive the GPS signals here, and it uses the same LoRa IC for LoRa communication. There are two reasons I became interested in these two products. First, I'll be traveling to Asia again and wanted a backup communication option like I said before. Second, I have been considering using LoRa in my next projects, possibly in a device like a bicycle computer that lets you track the location of your cycling partners. It will allow each device to share its position, display it on a map, and exchange data such as speed around your area. With that in mind, please let me know your thoughts in the comments. JLCPCB is sponsoring this video and I thank them for their support. If I were to make such a project, I would use their services again without hesitation, as they do an excellent job. So if you are considering producing your own PCBs, you can trust their services. I'll include the link in the descriptions. Just send them your design and they'll professionally produce your PCB quickly, whether it's a simple design or a more advanced project. Also, if you are not very skilled at soldering like me, you can use their assembly services. In addition to delivering high quality results, if you choose parts from their library, you don't need to worry about getting the best price, as they almost always offer the most affordable options for the components in their library. I got 868 MHz version of these because the largest LoRa mesh network operates at this frequency where I live. I recommend choosing the version that matches the coverage and regulations in your own region. If you want to check which mesh network operates in your region, visit meshmap.net. It lists the mesh coverage and supported devices worldwide. For example, my region mostly uses EU868 and long fast channel. To join an existing mesh, your device settings must match your regional configuration, otherwise you'll be isolated on your own network. If we go to Taiwan, they are using a different channel and also different frequency. I was also surprised to see that Taiwan has one of the most densest mesh networks in the world. Very cool. The Taiwan network is around 920 MHz. I have 868 MHz version, but it should still work to some degree. Worst case, I can just send my message by hopping through one of the existing nodes. And now it's time to travel. A long flight is ahead of me. Hopefully I'll be able to use these LoRa modules at least to some extent. I am currently in Hong Kong and waiting for my connecting flight. My friend and I got separated, so I wanted to test this while inside the airport. By the way, Hong Kong has a free Wi-Fi, so this test is entirely redundant if you are using this airport too. And inside of the airport it works very well. I have no idea about the range for now though, I will test it later. Finally arrived in Taiwan after 20 hours. Almost all the electronics you own have at least one component made here, and people here are rightfully proud of that. I arrived at hotel and now I want to configure this once for the Taiwan mesh network. If I don't, I won't be able to use the existing nodes to hop through. You can set everything up manually after powering them on, but there is also a simpler way to do it. In almost every country, there are Meshtastic community groups, and Taiwan is no exception. These groups provide setup guides that help you to configure your devices to join local Meshtastic network and communicate with other nodes. To find your local group, simply search for Meshtastic plus your country in your preferred search engine. Then you should follow the instructions provided by the local Meshtastic group, in this case the Taiwan Meshtastic community, which has written detailed setup guides. However, there is also a much simpler method. You simply tap the QR code on their website from your phone, and it automatically opens the Meshtastic app with all the settings for that mesh networks plus MQTT settings. Then you click the replace or add depending on your case. I will click replace option for now because there are no other mesh networks which my devices belong to. Not all Meshtastic groups give this option, but I really wish they did. It would make joining the network much easier for newcomers and greatly simplify the setup process. I am now going to perform a range test. This device is connected to 3 nodes for now. I will place one of the device inside of the car. I already have a disadvantage due to the frequency mismatch, and this will introduce a second handicap. I'm near to Tamsui River, which divides New Taipei and Taipei City. For this test, I also rented a community bicycle to move around and check coverage. For this test, I put my phone in airplane mode, turned off the Wi-Fi, and connected to the device only through Bluetooth. And if I check the number of the nodes I'm connected to right now, it is 4. One of them is the node that I left in the car. And my car is just over there, the white one. I am about 100 meters away from it at most. I'll send direct text messages to other devices as I go. Let's call this location 10 meters since I can still see the car. The tick here means my message has been acknowledged by the other device. Alright, let's hop on the bicycle and move a bit further. As I move along the river, my device keeps picking up new nodes. I've already found 14 nodes in just 5 minutes. I am going to cycle over that bridge and do a second measurement. Okay, I arrived under the bridge and my car is over that way, and we are connected to 20 nodes for now. I've also downloaded an offline map of Taipei, so I'm not connected to the internet still. The heart icon is where I parked the car. I am interested in the bird's eye view distance, and the easiest way to estimate is by using the scale at the bottom right of the Google Maps screen. The distance to my car from this location is roughly 300 or 400 meters. Let's send another message. I'll call this one 400 meters. This one is taking some time. By the way, I'm currently connected to 22 nodes. Let's see how long it's going to take. I'm directly under the bridge, so it might be interfering with the signal transmission. And now it's delivered. There's a nice bicycle path here, and I am just following it. It's quite flat, so there aren't many natural obstacles like mountains. Only the bridges might be affecting the signal transmission. Even so, I don't think they are really a problem here, because I'm connected to 41 nodes right now. And the distance between me and the car is around 1 kilometer. Let's see how long it will take this time. Last time it took like 10 seconds. I wonder how it is going to take this time. Yeah, now it's delivered as well. I am now near the 2.5 kilometer marker of the Xindian River and a bit farther from the city center. From this point on, there are only suburbs. Along the way, my node picked up signals from other 55 nodes. I am now roughly 4 kilometers away from where I parked the car. Let's see if other nodes can pick up the signal from this distance. This time it's picked up instantly. Pretty cool. I am quite far from the city center and I am in a residential area now. The river I was following runs in front of those apartments, and that's also another residential area. The city center is in that direction, and because of the river and the park, there are not many obstacles for the LoRa signals, and I therefore expect it to pass through with minimal interference. My device has now picked up signals from other 74 nodes, and I am like roughly 5 to 6 kilometers away from the car. Let's test how long it will take for the message to be delivered. Well, instantly. Let's cycle back to city center and see how it will perform there. I am now in the city center, standing in front of the Chiang Kai-shek Memorial Hall. It is again the same distance to my car, 5 kilometers, but I don't think there is a LoRa repeater or node inside of the monument, so I wonder whether my message will be delivered, because the car is located behind the Memorial Hall. I tried it a few times, but my message is not delivered this time. Let's change the orientation and see whether it will affect it or not. Well, nothing is helping. So in this location, unfortunately, my message is not delivered. Even if I raise it, the message is still not being delivered. Unfortunately, when there are obstacles like this and no repeaters within the reach of your node, you can't really hop through. There are many other nodes in this area that I am connected to, but my hopping limit 6 times is not enough to go around this large monument, which is a bummer. I am now in the business district. I am roughly 4 kilometers away from my car again, but this time the path to car is blocked by hundreds of buildings. However, there are many nodes between my car and my current location. I don't have a direct connection to the other node, so my message needs to be delivered by hopping through other nodes. Let's see how long it will take this time. Areas with tall buildings are the most difficult for LoRa communication, unless additional nodes or repeaters are placed on top of these high rises. This time it took almost 20 seconds, but the message was successfully delivered. Honestly, I had very little hope it would get through. It's because I'm barely within the coverage range of the nearest node. I walked like maybe 3 minutes to here from my previous location, and these buildings are blocking the signal path. And my message is therefore not delivered. Maybe it would work if I move up a little. I was near to the bicycle racks over there and walked about 20 steps away from them, and I believe this building was blocking the signal before. But now at least I have some clearance around me. Let's try sending the message again to see if it works this time. Yes, it's delivered within seconds. Since I am convinced that LoRa works well in urban environments, I decided to test it in remote areas as well. Taiwan has excellent natural reserves and hiking trails, which I enjoyed very much. I'm also alone because I couldn't convince my friend to join me. It's very windy today and raining quite a bit. But I gave the other one and told keep looking to that LoRa module so I can test this. This place feels very remote as it's in the northern part of Taiwan, but it's still quite accessible, so I expect the LoRa to perform well here. The message reached the other node within seconds from about 10 kilometers away from the hotel. LoRa's range is very impressive when it works. However, I wouldn't trust my life to mesh network in its current state. If you go to truly remote areas, there are essentially no nodes, and your message will not be delivered at all. This is my last day in Taiwan, and LoRa helped me quite a bit during my travel. Overall, I was able to use it in most places. It's not comparable to GSM networks yet, of course, but in a situation where all base stations stop functioning due to a disaster or similar event, I think it could definitely be used as an emergency communication protocol. And joining the mesh network is quite straightforward. You just need to buy a device and configure it according to your region. Unfortunately, the LoRa mesh network in Europe is not very well developed, but I think creating an alternative communication system like this there would be a great idea. I'm curious how other countries are doing in this regard. Please let me know in the comments, and as always, if you like this video, don't forget to give it a thumbs up, and see you next time.